Alright everybody, thanks for tuning in. Today we're going to go over replacing a clutch on a modern Japanese sport bike. First thing you're going to want to do is locate the clutch cover, which this is a 2012 Yamaha R1. Most bikes will be very similar to this. Some might have a sight glass for the oil on here. The difference between those is you're going to have to empty the oil out of the bike first, or at least to the point where you're below the sight glass. That way when you take off the cover, oil doesn't come out. In order to take off the cover, you have to release the cable from the cam. The cam is what actually pulls the clutch open. It pulls on this guy right here and lifts this up, which pushes against these springs. They sit inside like this, so if you can imagine pulling up against the springs to separate the clutch and allow the disc to spin freely. Let me go ahead and show you guys on the bike something you may need to do to help out with the removal of the clutch case cover. Okay, sometimes we need some extra slack. What we can do to get the extra slack in removing the clutch cable from the cam is to take our slack all the way out of our clutch cable, which ultimately gives us more cable down on the bottom and allows it to be a little easier to remove. Alright, removing the cover is pretty basic. You're just going to have your Allen bolts on top of the cover. Just go ahead and pull those off. This particular bike has a cover over the cam and the cable, which you have to remove as well. It's real easy. Another couple bolts, comes right off. And then that brings us to the clutch hub. And you're going to have your springs inside as so. And all you have to do is back these out, but you need to make sure to back them out evenly. So you would have 6 on this bike. Do a few turns on this and a few turns on that. Let's say 3 and 3. And then keep alternating so that you evenly release the clutch hub and that there's never an isolation of pressure in one side or the other of the clutch. Once you're through there, you get to a conglomeration of friction disc and steel plates, and they will be alternating. I have mine separated already. You're going to want to go ahead and pull those out. You can see the issue with this bike, it was slipping. This friction plate cracked. What that allows is these plates to slightly overlap, just enough so that it doesn't come in contact with the steel plate the way that it should. And what it'll do is it'll cause slipping and heat the steel plates. And sometimes these steel plates can become warped if they get too heated, too hot. The oil will cool them down fairly rapidly, and that will cause warpage. And we'll go ahead and check for that later. Here's the hub that we are pulling the friction plates and the steel plates off of. One thing that can help, see these holes up top here? What you can do is stick a flathead screwdriver in and pry on the clutch disc, the steel plates and the friction plates, just to get them to back off so that you can pull them out. The steel plates are of course steel, so they're ferrous, they're magnetic. Having a magnet is a nice tool to place on top of the steel plate and then go ahead and back it out. That works as well. One thing to note, I went ahead and cleaned my mating surfaces already. Make sure that you guys clean your mating surfaces. You don't want anything coming in between the mating surfaces causing a leak. Now you can see there's a little bit of residue just right here. You can't even feel that with your finger. It's really just a bit of discoloration and nothing to worry about. But anything you can feel with your finger needs to be removed. I use brake cleaner and a rag. And I shouldn't tell you this, but sometimes a razor. You need to be very careful, especially with aluminum cases, which these are, because you can easily gouge the aluminum if you are too aggressive with a razor blade. but they do wonders in removing gasket material. Okay, so now that we have the clutch open and we have our friction disc and our steel disc removed, I'm not even going to show you guys the procedure to check the friction disc. Reason being, if you go to the point that you open up your clutch hub and get all the way to the friction plates and the steel plates, you should go ahead and replace the friction plates. They are cheap enough to where it's worth it and it'll save you time later on. Even these here, these are the old ones. They still have a pretty good amount of life in them. You can see that they're not fully worn down, but because of the cheapness in replacing them, I'm just going to go ahead and do it and not have to worry about it, and I know I got a good set going back in. Typically you can get a set of friction disc for anywhere between $60 to $100. And your steel disc, you don't need to replace them. These ones are for racing. They handle heat a little bit better, so I do have these in the bike. This is an EBC street race package, I believe. Steels, and then I have stiffer springs as well, which actually help aid in the force, the clamping force between your friction plates and your steel plates. That's another thing you can do as well, but you don't need to. Just make sure you do the friction plates, but you can also do the steel plates and stiffer springs as well. Just keep in mind that when you do put in stiffer springs, that the clutch feel will be stiffer as well. So it's something to keep in mind. One thing that you can do is alternate your springs to kind of get a midway balance between stiff and stock. So say this was a stiff spring and this is a soft spring, you can go stiff, soft, alternating on the clutch hub, and that will give you a bit stiffer, a bit more firm clutch, but not too stiff if that's something that you're worried about. Okay, and then we're going to go ahead and move into checking the steel plates. Typically, you don't want to exceed 0.1 millimeters of warp, which is about 4 thousandths. Easiest way to do that is if you have a true flat surface, which I do. This is a flat steel plate that I use just for this purpose. I also have a straight edge that I use for this purpose as well, for doing heads and other things. But for steel plates, this seems to be the easiest. You just want to make sure that you can't get the 10 or the 0.1 millimeter feeler gauge anywhere inside of the steel plate without having resistance. Now you should do this with one hand on top. I can't because I'm holding the phone in my other hand, but you get the idea. It should hit and stop just like that. There we go. If you're able to go in too easily where it just slides right under and doesn't actually, something like that, then you have a warp and you want to replace your steel plates as well. Okay, so the most important thing with the friction plates when you put a new set in, you want to soak them in oil for at least 2 hours. This allows the disc to absorb the oil that they need to function properly and work smoothly. Without the oil, you'll notice that when clutch disengagement, when you disengage the clutch, you will feel a little bit of almost like a gritty feeling as you are in the friction zone. It won't be smooth, and it'll actually potentially cause damage to the friction plates. So what I do is I just use the bag they come in, cut a hole in the top, and fill the entire bag with oil, and make sure that the plates are soaked. So that's what I recommend there. You can put them in, a bucket, but it's easiest just to use the plastic bag that they come in. So I want to take a minute to point out why you really want to make sure you clean and inspect each part of the bike as you're taking it apart and putting something back together. As you can see here, I found a crack in the clutch carrier that runs all the way through. Let's see if we can get it better. There you go. Now, this carrier has never been out of this bike. It's never been unscrewed. Why we have that problem, I don't know, but we have a problem and it needs to be addressed. If I wasn't, paying attention to detail, probably wouldn't have found that, and that's probably the actual root cause of the extra stress on the friction plates causing them to break. I'm sure when this is stressed, especially clutch up wheelies or getting on and off the throttle, that this basket is torquing a little bit, causing some extra wear. And as you can see around the crack, we have some fraying of the edge of the basket. Very, very, very important to pay attention to detail. So now I'm going to go ahead and order a new part, check anything else that can be stressed because of this, and return to finish the job. Alright, just want to take a second to analyze something. See these little ribs that form? Those are normal. The clutch plates slide back and forth and they don't slide very far. So with a little bit of stress, they do dig into the clutch basket ever so slightly. What is not normal is to have wear like this, where it's really pitted into it. You can actually see divots inside the basket. So that's another sign that this crack was causing a lot of problems as the bike was in motion, which now I am sure was the cause of the fractured clutch plates. Okay, so I wanted to take some time to show the operation of the clutch basket and the clutch carrier. So this is a slipper clutch, which means that the clutch is allowed to slide the disc on top of each other as if the clutch was pulled in on deceleration. So what that does is allows for a little bit more consistency coming into a corner. It's not so grabby, a bit more smooth. So it operates by ramping itself outwards on these slides, which are normally full of oil inside the engine. And what that does is it, see if I can get it on here and show you. Okay. So what that does is as the clutch decelerates, the basket will slide up like you see there, just enough to pull off the stress from the clutch plates. So when that does that, it removes load. So you need to be careful because you can misalign the basket and the carrier. So you just need to be very, very careful that you have the slides on top of the ramps. That way it'll work accordingly. So these are the springs that adjust how much slip you get. So notice that there's 3 of them here. You can actually adjust the amount of slip by the number of springs or different material that you have. This is a more advanced thing that some race teams will do. For standard riding, I wouldn't worry about it. The engineers know what they're doing. It's been tested. Run what's in there. But as you can see, get a better angle here. What happens is the clutch carrier will actually press up against the base of these retainers and bend it and actually force it out to allow the slipping to occur and the springs push back down. Pretty basic. As we get these back together, we want to make sure we have proper torque specs. This particular bike is 69 foot-pounds. Make sure you guys check the specs. Sometimes you can Google them. Sometimes you can find a service manual online. but it's totally worth it to do it right. Some people don't have a clutch holder tool. Sometimes what you can do to keep the basket from spinning is stick your screwdriver through on this side up against the basket. The carrier won't move, the basket will with the screwdriver up against it. Mind you, you're going to want to angle it down so that when you're torquing clockwise it won't spin. But for 69 foot-pounds, I should be able to do it without causing damage to the basket. Make sure you use a rag or something so it's not metal on metal. And it's not ideal, but I know a lot of people at home that don't have the proper tools. That's the easiest way to do it. Alright, now that our nut is on and tightened, we want to make sure that we punch the top of the nut down into the recess. That will actually lock it, make sure it doesn't back off and potentially cause catastrophic engine failure. From here, you're going to add in your friction plates and your steel plates. You're going to alternate. Start with your friction, of course, as this operates like a steel plate, and the other side does as well. It's pretty basic. Just make sure that you put back in the right number of steel plates and friction plates. Alright, so now we're down to our pressure plate. Make sure that it's nice and clean, surface is uniform. You want to check the bearing on the inside, make sure that it spins fluidly, no dragging, no snagging, nothing like that. If it is, you will need to replace it. It should be spinning just like this is here. Down below we have our pull rod. Make sure that the pull rod is inside of the pressure plate. Can't tell you how many times I've forgotten to put it inside and had to take it back off again. And then once that's on, it's pretty straightforward. It's as easy as lining it up and putting it on. And now we have our springs that need to go in, our clutch springs. Make sure that we alternate those as you're putting them in, and as you're threading them in, do 3 or 4 turns on one, and then 3 or 4 turns on the other, and then 3 or 4 turns, 3 or 4 turns, 3 or 4 turns, 3 or 4 turns, until it is all the way down. This will keep the pressure on the pressure plate uniform and even as you are snugging those down. Something with clutch springs, I like to use aftermarket clutch springs that are a little more firm. Make sure that the clutch won't slip under heavy load. Clutch up wheelies, and just for racing, which I was doing in the past. Hopefully I can do it again in the future. You can alternate your stiff springs and your soft springs. Just keep them right next to each other, alternating as you go around. And that'll give you a medium upgrade as far as your stiffness without making it too hard on your on your wrist. These days with auto blip and quick shifters, the need to use the clutch has become a lot less, really just on starts, but that option's still there. Alright, we have our spring bolts snug. When I say snug, I just mean like very lightly snug. The torque spec on those is 7.2, and if you go somewhere around 15 foot-pounds, you'll probably snap those right off and have to use other methods that aren't so fun to get them out. So make sure you use a torque wrench. I'm using an inch-pound torque wrench. Mind you, my torque spec is 7.2 foot-pounds, so I'm multiplying by 12 to bring this to 86.4, which is exactly where I'm at. So I'll snug those down, and then we get ready to install our cover. Alright, before we apply our gasket, we want to make sure our cover is clean inside and out, and make sure that our seal for our clutch rod is nice and clean, no leaks. This will be the time to replace that if there are any problems. You don't want to try to put the cover on with the locating tabs in it and the gasket dangling from those. What happens is you try to put it on and it starts to fall as you go, and then you end up pinching the gasket and you have to buy a new gasket and put the cover on all over again. Not worth it. For those that want to know how to properly remove these, I do have another video on that on my page. that will help you to remove them without ruining them. Alright, so depending on the bike, this part can be a little bit tricky. We want to make sure that the pull rod teeth are facing towards the rear of the bike, as vertical as possible. That'll allow us to align with our clutch lever on the inside of the case. Alright, so as we get the cover on, we want to make sure that this dot right here at the base of the shaft aligns with the triangle. When we end up having this cover on, those two should be aligned. Good luck. Sometimes it can be a bit tricky, it takes a few tries, but with trial and error you will get there. Our triangle and our dot are lined up exactly like we want. We'll go ahead and bolt on this clutch cover in an alternating fashion. Once again, lightly snug them in. I'm pretty sure the torque spec is 7.2 on these as well. I will go back and check to verify. Alright, so all of our clutch cover bolts are tightened, and it is 7.2 foot-pounds torque. I do have a JB Racing engine cover on there. With racing, you have to have engine covers. This is now a street bike, but I kept those on for protection. So now, all we need to do is attach our clutch cable. It's a bit different for different manufacturers, but basically install it the same way that you took it off. And I may go into more detail on that here in just a second. Make sure that when you guys do start the bike, that you have the clutch pulled in. Okay, so we have our clutch cable installed. We want about a 1/2 inch of free play, which is right about what we have. If you have that 1/2 inch, make sure it's not completely snug. That'll put pressure on the pressure plate the entire time and cause the plates to slip prematurely. But just about a 1/2 inch is exactly what you want. It'll rest in here, won't feel like it's really loose, but that's exactly the amount of play that you want. And that's how you replace a clutch.